Hello, and welcome to this review and walkthrough of the periodic table mystery activity. And so the purpose of this activity was to kind of um, reintroduce and go through some of the things that we discussed in lecture, and as far as kind of the organization of the periodic table and how some of those things kind of go. There were also some other concepts brought in that were not necessarily things that we have seen yet. And so I know from some of the feedback, those were the majority of the questions that we had. So let's take a moment here, and I'm just going to walk through each of these and give you the correct answer and also how we knew it was the correct answer. So the first thing that we had to know, the first thing that we could understand is that each of these 8 groups corresponded to the 8 groups given here. And so automatically I look at group 2 and 3, and I can say with groups 2 and 3 that since these 2 groups had 4 elements each, one of them was group 1 and one of them is group 18. So one of these is alkali metals, one of these is noble gases. Now, the other clues that we can get are from some of these other things. So if I go to my first clue here, U has a total of 6 electrons as a neutral atom. Well, that means that U is carbon, and carbon would be found in group 14. So I don't know much other than I know U is right here, but I'm going to put GUN on top of group 14 because I know that if U is here, G and N have to be there somewhere. It's just a matter of where. So I'm just going to cross that one out real quick. So that was clue number 1. I2A is a common metallic oxide. Okay, so here I'm talking about I. So I is in this subgroup here, PSIF. Well, if it's an oxide, it's not going to be a noble gas. It's also metallic. So I don't know a whole lot here, but I know that this group goes right there. So again, I'm going to leave that for right there, which means by elimination, this group, JXBE, must be the noble gases. So I can cross that group out there as well. We're told that S is an alkali metal. That doesn't really help us. We're told E is a noble gas. Also doesn't really help us. We've already deduced that. Let's look for some other ones here. Okay, B has 10 protons. Okay, well, 10 protons would be atomic number 10. That's neon. So neon is right here. So we've got that one figured out. We're told that O is a halogen. Okay, well, WOV. So group 17 is the halogens. So it goes there. We just don't know where yet. We know that C has 5 outer electrons. So we haven't discussed this explicitly yet. That'll come in our next module when we talk about electronic structure. But C is, so 5 electrons in the outer level means that it's going to be in group 5A or group 15. So that means that Y, M, and C are here. So we've placed that one now. And we've already placed WOV. So at the very least, we're starting to put these into the correct locations. We just need to kind of finish it off. F is a colorless gas. Well, PSI and F are group 1. The only one of those that would be a gas is hydrogen. So that gives us F right there. R is a common metal used to make sheets and foils. Best guess there is that R would be aluminum. Now aluminum would be right here, period 3, group 13. And we haven't placed R yet. So the group is ZRD, and R would go right there. X has a atomic number 1 higher than F. Okay, well, we already just put F here, so that means that X must be here. So X is helium. Y is a metalloid. Okay, well, group 15, that's the nitrogen group. So we've got nitrogen, phosphorus, and arsenic. Of those three, arsenic is the metalloid, so that means Y is right there. And so what I'm going to start doing now is we're gonna kind of look side by side at the periodic table, and because we're starting to match elements up, note for note, piece by piece. So it's going to make a lot of sense for us to kind of have a reference for them. So again, if I'm looking at group 15, the thing that we remember, that staggered staircase starts here between the boron and the aluminum and staggers down. That's how we knew arsenic was the metalloid in that group. O has a lower chemical activity. We'll come back to that. We haven't really. T has a higher chemical reactivity. Again, we have a real good spot for that. We haven't placed QKA or LHT. So we need to try to figure out where those are. And so let's see. Okay, right here, we missed this clue. This is a really important one. L is the heaviest alkaline earth metal. Okay, so that means that LHT is here because group 2 is where the alkaline earth metals are. L is the heaviest of those, so that means it's right there, which means it's calcium of the ones that we're looking at. Since that is LHT, that means that group 16 has to be QKA. So at the very least, even if we don't get all of the properties correct the rest of the way through, we've at least placed all of the groups in the correct locations. Now it's just a matter of following out some of the key trends here. And so I'm going to come back to the top here and see if there's anything else I can glean now that I know where everything goes. Okay, so P is less dense than S. Doesn't really tell me a whole lot here other than P is probably higher than S, but I don't know where P, S, and I are in relation to each other. W is liquid at room temperature and non-metallic. Okay, important clue there. We know that W is a non-metal and it's liquid. The only non-liquid the only non-metallic liquid is bromine, and bromine would be this one right here. So if I'm looking at the periodic table on this side, the bromine is in group 17, period 4. So that would be this box right here. So we know that this is W. So we can cross that one off of the list. Okay, Z has the highest ionization energy of its group. Okay, ionization energy is not something that we have talked about. It's the ability for an atom to have an electron taken from it. easier it is, the less energy it's going to take. This is going to require the most energy. Now, the periodic trend here for ionization energy, as you go across the periodic table and up the periodic table, ionization energy increases. So if we've got the highest energy in the group, that means it's at the top of the group. And so that puts the Z right here and the D right there. Now, that goes kind of hand in hand with this other clue about D having the lowest electron affinity. I got a number of questions about this, because if you actually look at the electron affinity of boron versus the electron affinity of if you actually look at the numbers, boron actually has a lower electron affinity compared to what we're comparing it, gallium. But what the activity was going after was the general trend. The general trend is that electron affinity overall decreases as you go down the table, as opposed to increases. So that's where that assumption was made. So we should have already figured it out based off of Z, because that one's definitive. But there could have been a little bit of confusion for you from D if you were actually looking up the numbers. Okay, O has a lower chemical reactivity and a lower ionization energy than V. Okay, so two things. Reactivity for nonmetals increases as you go up the group. And as we said, lower ionization energy. Ionization energy increases as you go up. So the lower ionization energy would have put the O down here, the V up here, but the chemical reactivity piece as well. So for nonmetals, as you go up the table, they get more reactive. For metals, as you go down the table, they get more reactive. And so in your comparisons between T and H, now we're on the metal side of the ledger. T is more reactive, so that means it's lower. J has an atomic number 3 times that of T. Well, we just placed T. T is in group 2, period 3. That's magnesium. An atomic number 3 times that would be 36. Atomic number 36 is a noble gas. So we're over here in period 4, group 18. And so I can put J now here, which means that E must be there. Q has an atomic mass twice of that of A. Well, I don't know Q or A, but I can look in group 16 and see that there's only one place where that would make sense, and that's for oxygen and sulfur. And sulfur has double the mass of oxygen. So that must mean that A is oxygen and Q is sulfur. And the only one that we haven't talked about is K, which must be selenium. Atoms of I are larger than atoms of S. Okay, again, all I know is that S is going to be higher on the table than I is. M is a smaller atom than C. Okay, so that means that C must be bigger than M, which means it's going to be further down on the table. The electrons of N are distributed over 3 energy levels. One of the nice things about the construction of the periodic table is that it does give us the number of energy levels. So a 3 energy level atom would be in period number 3. So since N is there, that means that G must be there. We already figured out K is the largest of its group. So now we just have to configure P, S, and I, the last piece here. And so we're told that P is less dense than S. and I is larger than S. Well, so by that kind of process of elimination, if P is higher on the table than S, because density does increase as you go down, and S is smaller than I, well, then the only logical explanation is that they must be in that order. And so hopefully this kind of helps you out. And if you got bogged down and stuck into the details here, this could have been a pretty frustrating activity. But if you followed along and you just kind of use some basic organizational kinds of ideas here, you should have at least been able to place the 8 columns correctly. And then if you did a little bit of digging, you might have run into a couple of things, but overall, hopefully you did okay with this. And if you have any questions, please feel free to reach out to me, and I'll answer them in whatever way I can. But until then, I'll see you in class. Have a good day.